I've shared today's questions with you on this notebook. Can you please look at the questions? These are collective questions from previous quizzes. And we will go through the questions today. Okay. You don't need Mathematica to do the questions, but you can always use Mathematica to check. But in the real quiz, you don't need Mathematica at all. I'll go through these questions one by one, but I'll do only use in hand calculations. Let's look at, I hope you have the questions with you. So I won't share my laptop screen because my laptop has the questions, but I'll use the iPad to compute the solutions. So I'll share my iPad with you. Okay. You guys have the questions with you, right? Okay. Let's go through question 1. Okay, in question 1, we are given the sets U, A, and B. B is given. U is a set with all positive integers less than or equal to 10. A is the subset in U, where every element is bigger than 7, and which is the subset of U. Okay, so the first part is write all the elements of U explicitly. Okay, so we are given U is equal to X in C plus a positive integer such that X is less than or equal to 10, which is equal to 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, and that's part A. Part B is write out all the elements of A. So A is an element, X is an element of U such that X is bigger than 7, which is, these are very easy questions. So bigger than 7, we have just these 3 numbers, 8, 9, 10. Okay. And part C is what is A intersection B? Intersection are common elements from both A and B. So A intersection B equal to, we need the set B. B is 1, 2, 3. So compare A and B. Do you have any elements common to both A and B? No. So it's a empty set, which you can write it like this or just like that. Okay. Part D is what is A union B? which is equal to all the elements in both A and B. So 1, 2, 3, 8, 9, 10. Okay. And the next question is, what is A complement intersection with B? To do that, we need A complement in U. A complement is all the elements in U without these elements in there. Okay, so everything except 8, 9, 10 in U, that would be 1, 2, 3, 4, 5, 6, 7, and A complement intersection with B. Okay, intersection with B, we got just 1, 2, 3, which is the set B. Okay, and part F, what is the Cartesian product of A and B, which is the set containing ordered pairs from A and B. Okay, so look at A and B. I'll write A here as well, 8, 9, 10. Okay, so that's set B. From A, okay, we got 8 as the first element. From B, we have 1. By the way, ordered pairs are expressed using the round brackets, and a set is expressed using a curly brackets. And okay, the next ordered pair would be 8, 2, 8, 3, and the next element in A is 9, with 1, 9, 2, 9, 3, and the next one is 10, 1, 10, 2, 10, 3. Those are the Cartesian product of A and B. Okay. Remember, the first element should be from A, and the next element should be from B. The next part is part G, which says write the elements of the power set of B. Power set contains all the subsets of B. So power set of B equals, okay, B is here. I'll write all the single elements first, single subsets. 2, 3, and subsets containing 2 elements, 1, 2, 1, 3, 2, 3, and subsets containing 3 elements, 1, 2, 3, and what else is missing? Yeah, the empty set is missing. Okay, empty set is missing. So by the way, you can determine how many elements would there be. That would be 2 to the power the number of elements in B, 2 to the power 3, which is 8 elements. Okay, good. There is a question. Question C, about question C, could we just only write empty set? determine this? I think the meaning would be the same, but if you want to use the set symbol, it's better to use the set symbol. My guess is it would be still acceptable. Okay, for question 3. What is the number of elements in the power set of B? We just computed that. That is 2 to the power, the number of elements in B, which is 2 to the power 3 equals 8. Okay. I hope that's clear enough for question 1. Is there any question? Everyone is okay? Okay, good. Question 2 is about properties of sets again. We are given sets A and B. Again, similar method. A is 0, 1, 2, 3. B is 1, 2, 4. We got to determine A union B, which is pretty easy. I think I mistakenly given the answers. No, there's a mistake. Oh, I didn't give the answer. Okay. A union B contains all elements from A and B, which is 0, 1, 2, 3. 0, 1, 2, 3. 1 is here, 2 is here, 4. Okay. And A intersection B. A intersection B are common elements from A and B. We got 1 and 2 common. C is again the Cartesian product of A and B, which are ordered pairs. The first pair element of the pair should be from A, so it's 0. The second one should be from B, 0, 2, 0, 4. Sorry, I think I missed one. Yeah. So that should be 0, 3, 0, 4. The next one is 1, 1, 1, 2, 1, 3, 1, 4. And the next one is 2, 1, 2, 2, 2, 3, 2, 4. This one should be 3, 1, 3, 2, 3, 3, 3, 4. Okay, I'm going through these quickly because I am assuming these are very easy questions. B is 1, 2, 3, not 1, 2. Yep. Thanks. The next one is 2 to the power the number of elements in A, which is 2 to the power the number of elements in A is 4 elements, which is equal to 16. And part E is C is a subset of A, such that the number of elements in C equals 3. And what does that gives you? The number C is a subset of A such that the number of elements is 3. Is equal to, I think I missed one question. Okay, don't worry. Which gives us 24 sets can be possible. Why? There are 4 elements, okay, in A, so you choose 3. Okay, 4 choose 3. What does that gives you? That's 4 factorial divided by 3 factorial, 1 factorial, which is equal to 4. So there should be 4 subsets. Okay. What are the 4 subsets? You can write down if you want. 0, 1, 2, 0, 1, 3. And the next one is 0, 2, 3. And the next one is 1, 2, 3. Okay. So those are the subsets. I think there is another question which, like, that's one question I meant to give you, but let's do the actual question in part D, which is but part E. C is a subset of A such that number of elements of C equals 3. Complement with C is an element of the power set of A such that number of element is also 3. Okay, what is the outcome? C is a subset of A such that number of elements is 3, which is this, which I have written here. And then C is the element of power set of A such that the number of element is also 3, which is the empty set. And the other one, maybe you have done this in the class. I'm not sure, but I just want to give this. R is a subset of the Cartesian product, where R is a function. Okay, number of elements in that set. So this set counts how many binary relations are there in A and B. Okay, so for each element of A, okay, there are 4 possibilities. So because A has 4 elements, you got 4 to the power 4, which is the number of, okay, you should be able to count this 4 to the power 4. Okay, that's the last question. Okay, the next question is logic. Consider the following logical expression. A or B, and not. I think in your lecture notes, not is given as this. Not. Okay, but that doesn't matter. Oh, it's the same. Okay, good. So let's say not A and B. All right. So the actual question is, consider this operation. Write the truth table for the above expression. Okay. This table I created. You could create your own table if you like. So to fill in the table, let's say A, B. A can take T, T, F, F, true, true, false, false. True, false, true, false. Then what is A or B? Okay. That's true if either A or B is true. So if both are true, that's true. If one of them is true, that's also true. Here also true, that's false. Okay, the next one is A and B. Okay, that is true. Only both are true. So both A and B are true. So that's true. False, false, false. And the next one I've asked is, so we got this part, and then not A and B. Not A and B. Which is the opposite of that? So if it's true, not is false. True, true, true. And the last one is, because we have that part, we can write the statement A or B, intersection, A and B. Okay, so it's this part and that part. Okay. Again, because and for and is true if both are true. So true and false. Look at this. True and false would be false. False and true. Sorry. False. Yep. I got that is Oh, I'm looking at the wrong one. Okay. Should be this one. Okay. True and false is false, and true and true should give us true. And true is true, false and true is false. Yeah, that's right. Okay, so the last column is FTTF. All right. Part B is write an expression using only and or not that is logically equivalent to the above expression. You can write, there are so many possible choices. This is like XOR operation. And if you can show that like logically equivalence using the truth, using a truth table, okay, that should be fine. So let's say, for example, the statement A and not B, or not A and B. Okay. If you want to fill that table which I gave you, you can. I have skipped here some of the steps, like I didn't use not B. You can use not B if you want separately. Not B. And not A and B. The next one is the statement A and not B, union, not A and B. Okay. When I fill the table, this is true, true, false, false, and that's TF, TF. Okay. Here I got FT, FF, and F, T, F. So you can compute the statement, the truth table for the last column. This is a or statement. So F false, false should be false. True, false is true. False, true is true. False, false is false. Okay. So you can compare the last column with this one. Okay. If that's the same, they are logically equivalent. Okay. All right. Is that clear? Yeah. The next one is proof. You're given sum of 2i minus 1. I goes from 1 to n equals n squared. Okay, you can use two methods to do this. One method is the usual method, mathematical induction. Induction has 3 steps. Okay, the first step is called the basis step. That is, you show this is the statement is true for n equals 1. Okay, that is sum I goes from 1, n equals 1, that is 2 times 1 minus 1, which is equal to, is that equal to 1 squared? This equals to 2 take 1 equals 1 squared, okay, which is true. The next step is called hypothesis step or induction step. Assume it is true. Is true for n equals k. So that means I equals to 1 k, and we got 2i plus 1 should be equal to, we got n squared, so that should be k squared. Okay. And step 3 is you show it is true for n equals k plus 1. Okay, k plus 1 step. How do we show this one? This is n equals k plus 1. I goes from 1. 2i take 1. Because, I'll start from the left hand side. This is up to k, sum up to k. 2i minus 1. Plus the k plus 1 term, which is equal to 2 times k plus 1 take 1. That is equal to, because the k step, we assume up to k the sum is true, so that should be equal to k squared from here, plus 2k plus 2 take 1, which is equal to k squared plus 2k plus 1, which is equal to k plus 1 squared. Okay, so okay, so therefore by the principle of induction, is true for n bigger than or equal to 1. Okay. Any questions for that? No? Method 2. Method 2 is you can expand the sum, which is very easy. Sum up to n. 2i take 1, which is equal to sum 2i minus sum 1, which is equal to 2 is a constant here, so I n I equals 1 minus, this is sum in number 1 n times, so that's n, and that's equal to, now this is 2 times this sum. In your assignment, you are asked to show that that sum is equal to half n plus 1, okay, and minus 1 minus n, which is equal to n squared plus n, which is n squared. Okay, that's the right hand side. Okay. All right. The next one is also proof. I'll use just in mathematical induction for that. Okay. This time the formula is k squared. K goes from 1. This should be n 1 over 6 n plus 1, 2 n plus 1. I think we came across this in the second track, where we computed this using Mathematica. So again, using mathematical induction, step 1 is show this is true for n equal 1. That's called the basis step. Sum k goes from 1, n equals 1. K squared equals 1 squared. Okay, that's the left hand side. Is that the same as if we have 1 by 6? N is 1, 1 plus 1. This is the right hand side. 2 times 1 plus 1, this is equal to 1 by 6 times 2 times 3, which is equal to 6 by 6, 1, equal to 1 squared. Okay, so it's true for n equals 1. Then step 2 is assume the statement is true for n equals k. That is sum I goes from, sorry, did I say k? This should be equal to k, 1 by 6 k, k plus 1, 2k plus 1. Step 3 is the last step. Show that true for n equals k plus 1. N plus, that is the k plus 1 step. Okay, so I'll start from the left hand side. which is equal to up to n step, up to the kth step, which said it's true. So k equals 1, k squared, plus the k plus 1 step. The k plus 1 is k plus 1 squared, which is according to the assumption, the first term is 1 by 6 k, k plus 1, 2k plus 1, plus k squared is, k plus 1, k plus 1. We can expand this. This is, I'll take 1 by 6. K plus 1 is the common factor. And what is remaining is k, 2k plus 1 plus k plus 1, which is 1 by 6, k plus 1, that's 2k squared plus k plus k plus 1. Oh, something is wrong. That should be 6 times. So that's 6 plus 6 is k plus 1, 2k squared plus 7k plus 6. Okay, factorization of this part. This part should give you k plus 2, 2k plus 3. Okay, is now that's the left hand side. Okay, now is it true for the right hand side? When you apply the right hand side formula for k plus 1 equals is given by 1 by 6. N is now k plus 1, k plus 1 plus 1, 2 times k plus 1 plus 1. So that's 1 by 6 k plus 1, k plus 2, 2k plus 3, okay, which is the left hand side. Okay. Therefore, you can conclude by the principle of mathematical induction. It is true. It is true for all n bigger than or equal to 1. Okay. Okay, that's the first part. Question 7. Any questions? No. The next part is about linear algebra or counting. Question 6 is counting. Three identical dice are rolled, each with 6 sides, labeled 1 to 6. How many possible outcomes are there? Like, suppose if you roll 2 dice, with 2 dice, number of possible outcomes equals 6 power 2. 6 times 6, 36. Similarly with 3 dice. the number is equal to 6 bar 3. Okay, you can find out this. Okay. Number 7, linear algebra. You're given two matrices A and B. First part is set alpha is -1. So if alpha is -1, A equals 1, 1 minus 1, 1. Find x and y such that the system of equations satisfies the given A, x, y, I equals 1, 1. Should be easy. A is 1, 1 minus 1, 1. X, y is 1, 1. You can form two equations for this. This is dot product, okay, row by column. So the first equation would be x take y equals 1. Next one is x plus y equals 1. Equation 1, equation 2. Equation 1 plus equation 2, you get 2x plus 0 equals 2. So x equals 1. Okay? When x equals 1, you have from equation 2, maybe, you can sub it. You get 1 plus y equals 1. So y equals 1 take 1, y equals 0. That's the first part. It says identical dies. 3 identical dies. Okay, part B. Determine the product A times A. Determine the product A times B. A by A is for a general case 1, 1 alpha 1, 1, 1 alpha 1. Okay, you can do row by column multiplications. I got this is I'm skipping some of the steps, but you should be able to get. So that's 1 plus alpha. That's 1 alpha plus 1. That's 2. And alpha plus 1. That's what I got. And the next one is A times B, which is 1, 1 alpha 1. B is beta minus beta. You may wish to factorize this one, that is take out beta. Oh, there is a question about this one. Okay. This, I got the answer is 1 minus alpha, that's 0, 0. Part D. Given a value of alpha with alpha not equal to 1, for which values of beta does B equals A inverse? So what you can do is first compute what is A inverse, which is equal to 1 over determinant of A. And then you have 1 minus 1 alpha minus 1, which is equal to 1 over determinant of A is 1 minus alpha. Okay. And here we are given alpha is not 1. Okay. The question is for what values of B? What values of beta does B equals A inverse? Okay. Which means if we want to compute this, 1 over 1 minus alpha, 1 minus 1 alpha minus 1, which should be equal to B is beta times 1 minus 1 minus alpha. Okay, so comparing these two, B and A inverse, okay, what values of B, what values of beta that you can take? In that case, beta should be equal to 1 over 1 minus alpha, where alpha is not equal to 1. Okay. All right, it's 54. There remains 2 more questions. I will put the solutions on GitHub, okay? And is there any general question?
Sorry. I think just some error in A, and now it is D, and I think we need to go back A.
Sorry, is it question 7?
Yeah, 7A.
7, the first part set alpha is minus 1.
Yeah.
Oh. Maybe I made an error.
Oh, 7B, I think. B. I'm sorry. 7B.
We determine the product A times A.
I think the A multiple A and A1 2 is 2A rather than A plus 1.
Oh, this one?
Yeah.
Okay, so it's like this row times this one. So that's plus alpha, and that row, that's alpha plus, oh, good.
Yeah.
Plus. Thank you.
Yeah.
Okay. Yeah, that's 2 plus alpha plus 1. Now, okay?
Yeah, that's all. Thank you.
Thank you so much. 1 plus alpha. All right. Any other question? I got another tube, so I need to stop the recording. All right. See you next week, and wish you all the best for your quiz. Okay. Thanks for joining.